Okay, welcome to our last section of new material together. This has been a very, very fast moving term. You guys have been just such hard workers, and it's been a pleasure to walk through this term with you. But let's tackle our last topic here, introduction to functions. Just one more little piece of information before we wrap things up for Math 65. If the quadratics, the graphing, if that was getting a little heavy for you, this is just kind of a little change of pace here. And it's really not anything new necessarily, it's just more new vocabulary. Hopefully you've been introduced to functions before, but if it's brand new to you, trust me when I say that it will become clear. It's just like that first day you were told that x represented a number. You didn't know the number anymore, we'll call it x. That felt funky for a while until you got used to it, and now it doesn't bug you at all when you see x, y, t, r, d, any of these letters that can represent numbers. Same kind of idea. We're just going to talk about functions. Feel a little strange and unfamiliar at first, but you'll start to get the hang of it. It'll feel more natural as we go. Okay, so what is a function? Well, one way to think of it is it's a relationship. Where it's a relationship in terms of your x's and y's, your points on the graph. It's a relationship where each x value has one y value. Okay, so you take an x and plug it in, and there's just one possible y to get out of that equation, out of that function. In other words, there's one function, there's one job that this equation has, and so you put an x in, performs that job, you get a y value out. When you get multiple different answers out from the same x value, that's not a function. A function is just a one-directional, put something in, get something out. Okay, so, and that's another way you can think of it, as something that's happening to x. Or you can think of it as you input an x value and the output that you get equals the y value. Okay? Very simply, I call this the arrow method of determining whether something is a function or not. Let's look at a couple pieces of vocabulary before we jump in here. Domain. D-O-M-A-I-N. Domain is all your x values. All the x values that are possible in the equation, or in this case the set that we're going to be looking at. The range, well, if the domain is all the x's, the range is, you got it, all the y values. Okay. So if here's our domain right here of all the different x's that we have, imagine each one of these is a different x value. And then we have a lineup of the range. Over here, all the different y values that could come out of this function. And you start pairing up, you put in an x and you get out a y. So let's say we put in this first x and it gives you this particular y straight across here. Put in this second x and it gives you this y down here. Put in a third x and it gives you this y back up here. We put in this fourth x and it gives you the y, final y straight across here. Okay, so the arrow method says that if every x, so you match up all the x's and y's. So you match up the x's with their corresponding y's. How do you know? Well, that'll become clear in just a little bit. They're going to tell you the pairings. As we start this, they're going to tell you the pairings. What x goes with their y's. So match up the x's with their corresponding y's. And if every x, so you just focus on the x's, the domain, has only one arrow, very important. Every x has only one arrow leaving it. Where it lands, how many it crosses over, that doesn't matter. We just have one arrow leaving each x. Okay, then it's a function. those of you that have started to take maybe some psychology classes, development classes, how the brain works, how we learn, one of the things you want to do is when you teach a new concept, you teach what it is, but you also teach what it's not. So let's look at something that would be an example of not a function. If here's the domain, all the x values here, and here's our range. Here's all our y values. And we start to look at the pair up here, and the first one goes down to this second y. That's great. The second x goes up to this first y, but then the third x goes up to this second y, and the fourth x goes across to this y, and then the second x again, you plug that in and you get a different y value here. Okay, right here there's two arrows leaving this one x, so there's more than one arrow leaving. I don't care, they could all land on the same y, that part doesn't matter. It's how many arrows are leaving the x's, leaving from the x's. More than one arrow leaving x, any x. It only has to take one to cause it to not be a function, and it's not a function. Okay, so I kind of took that all the way down the page here, but let's look at how that plays out in real life here, in the real examples. I don't know how real life it is, but in the examples that we're going to look at. Here's the instructions. Determine whether each relation is a function. Give the domain and range. Sorry, a little typo there. That D should be scooted over. Give the domain and the range for each relation. So here is our set. We've got -7, 7, -5, -5, -3, -3, 0, 0. They give you a whole bunch of pairs, and the x's and y's happen to match right now. So whatever you put in for x, you get the same thing out for y. Whatever you put in, you get the same thing out. Whatever you put in for x, you get the same thing out for y. And so what you're going to practice is you're going to tell us the domain and range, and then whether it's a function or not. So right now, our method of doing that, I'm going to call it the arrow method. So give me a list of the domains here. All your x's are the first coordinates. These are just points on a graph. Those are your x's. So your domain here is -7, -5, -3, and 0. Your y values are the second parts of these points. They're the y coordinates of all these points, and so your range is that entire list of y values, -7, -5, -3, and 0. And now we drew the arrow. Let's match it up. Well, -7 matched up with -7. -5 matched up with -5 because they gave it to us that way. They're telling us that -3, -3 is a pairing. Put -3 in, you get -3 out. 0, 0 is a pairing. Put 0 in, you get 0 out. And then you look at the arrow test, and you look at the x's. And as long as there's not two arrows leaving any of the x's, as long as there's only one arrow leaving every x, so every x has only one arrow leaving it. I don't care how many are arriving at y's. I don't care if a y got left out or that any of them got more attention than the others. All we care about is every x has only one arrow leaving it. Then, yes, it's a function. And to be official, the official domain looks like this. You get to use the French, they're not really French, but those little braces that I seem to like so much. -7, -5, -3, 0. Typically in order like the number line would be from least to greatest. The range, in this case not very hard because the numbers match. -5, or it's -7, -5, -3, and 0 is the range. So you just list all the x's for the domain, list all the y's for the range. Okay, so the official domain and range. The domain, you just list the x's, all of them. And the range, you just list the y values. Okay? And then it's how the pairing up the arrow method that will tell you if it is a function or not.